Yo, Chuck.
Hey guys, got a cool algorithm today on a palindrome test using recursion. And I think it's worth mentioning just what recursion is. So, recursion in layman's terms is just a function that calls itself until it doesn't. So, let me give you an example of what that looks like. So, let's make a function called countdown. And it's gonna take a number, and I'm gonna call it countdown 10. I'll put in 10 there. And every recursive function should have a base case, and that is basically some like if statement or some check to see and basically stop the function from continuously running, because as I said before, recursion is just a function that runs until it doesn't. So it's going to call itself multiple times, most likely. So let's say if num equals 0, return. So that's going to stop it from running repetitively. And then now we're going to, let's console.log what num is above this so you can see the output. So we'll say console.log num. And then now we need to call the function again to make it a true recursive function. So I'm going to say return countdown. And if I was just to put in num here, this would run indefinitely and crash my browser because we're never going to reach this base case of num equal to 0. So that's a big thing with recursive functions is you need the base case, but you also need some type of like decrementing way or some way to reach your base case. So instead of putting just num, I'm going to put in num minus 1. Now let's run this function and see what happens. And ta-da, you see we start from 10 and just count down as num decreases because we're calling the function countdown with a number of -1 every time. So that's just a quick run through of like what recursion is or what a recursive function would look like. Now let's write our isPalindrome test for using recursion. So let's do that. I'm just going to change this to isPalindrome, if I can spell it right. And we're not going to take a number this time. We're going to take a string. And let's put in race car. Okay, so a palindrome, if you don't know, is just a word spelled the same way forwards is backwards. So race car is a palindrome. Taco cat is a palindrome. Soup is not a palindrome. Okay, so that's just a quick run through. So first things first, we need to make a base case as we did before. So I'm going to say if string .length equals 1, return true. And also I'm going to say if string.length equals 2, return string at index 0 equal to string at index 1. And I'm going to check for that. So I'm basically going to say if string at index 0 equals string at index 1, return true or false. Okay, so why am I making these base cases like that? Like, how do I know I should just make that my base case? So the strategy, or one of the strategies you could use for this problem, is we can test the first letter and the last letter to see if they are equivalent. And if they are, we can move further down into the word. So now we can test this ASCA. We can say, oh, is A equal to A? Yes, it is. Okay. And then we're going to slice down further. Now we're going to see, is C equal to C? It is. And now we're at E. And we've reached a string length of 1. Therefore, we know this is a palindrome, so return true. Likewise, if this was an 8-character word, let's say it's race car with 2 E's, this is also a palindrome. But instead of reaching that base case of string.length equals 1, we're going to hit the base case of string.length equals 2. And at this point, we're going to compare E to E and see if they are equivalent. If they are, return true. In this case, yes, they are equivalent. So that would return true. Okay, so now we need to somehow like decrement the function or make a way to decrease the length of the string so our base cases will catch and actually work. So what I'm going to do is I'm going to say if string at index 0, so if the first letter is equal to the last letter. And there's a little trick you can do to target the last letter of a string. You can just use string slice -1, and that is going to return the last letter of the string. So if that's true, then I want to return is palindrome. And then now I want to go deeper into the word because I said, hey, the first letter equals the last letter. That's true. Now I want to somehow decrement the string, and I'm going to say string slice at 1 to -1. So now we're just peeling back the onion even more, and we're targeting these letters right here because we said R is equivalent to R. Yes, that's true. Now let's peel it back even further, and we're going to compare this word now. Okay? And then I can say if the first letter is not equal to the last letter, then I know this isn't a palindrome right off the bat, so I can just return false. Okay, return false. So let's clear our console. This should work, hopefully. True, that's good. Now let's make something that's not a palindrome, like race cars. False, that's good. Let's try Choco Cat. This should be true. And let's try beer. False. So it looks like it works. Just to illustrate that chopping, or the slicing rather, of the word each iteration, I'm going to console.log the string just so you can kind of see it. I'm going to clear the console, and then I'm going to put in race car again. So you can see as it runs, it's chopping off the first letter and the last letter if they are equivalent. You can see it's kind of running. Oh, now it's hit our base case of string.length equals 1. So it's going to return true. So race car with 2 E's also is a palindrome, but it should trip our base case of string.length equals 2. Let's clear this out and let's see. And it does. So you can see here we start with race car. We're chopping off the first and last each iteration, until finally we reach the base case of string.length equals 2. Now let's compare these two letters. And they are equivalent. E does equal E, so we're going to return true. What if we took away one E and put in a Z? Now let's run it. And it returns false because E is not equivalent to Z. So this is pretty much the palindrome recursion in JavaScript. I hope you guys enjoyed this video, and I will see you in the next one.